I'm Anil Kumar on popular demand. Here is another test paper which is on trigonometry, identities and equations. So I've copied these questions from previous test paper. Let me congratulate the student for getting excellent marks, almost 100%. So this is one of the recent test papers. Here are these questions. I'd like you to pause the video, copy the questions, look at them, and then one by one we are going to solve them. Now if you see, first three questions are based on just expansion of compound angle formula a plus b or a minus b for sine and cosine and tan. Now in these questions, in the very first question, you could also use cofunction identities, right? Question number 4 is solve an equation square root of 2 sine 5x plus 1 where the domain is given between minus pi to pi. Remember sine 5x, so that will change the domain. Now question number 5 is also solving equation. Then we have to provide a counterexample to show that cos x plus cos 2x is equals to cos 3x is not an identity. So I hope you remember what is counterexample. Then the other 4 questions are kind of identities, very simple identities. So this test paper will really help you to prepare for your own test. Then I'll provide you with my test paper on the same topic. Let us go through these questions one by one. Question number 1. We need to simplify sine pi by 2 minus x plus sine pi minus x plus sine 3 pi by 2 minus x plus sine 2 pi minus x. Now let us do it without using compound angle formula. All these functions, we could write them in their equivalent form, right? So let us say that this is x. Now, when I say sine of pi by 2 minus x, then it really means what? It really means that we have transformed it to this position, right? So that is pi by 2 minus x. Now whenever you do this, in that case sine becomes cosine, and since you are in quadrant 1, it will be positive, correct? So let me rewrite this particular expression, which is sine pi by 2 minus x plus sine pi minus x, plus sine 3 pi by 2 minus x plus sine 2 pi minus x. Now the first expression, as you can see, sine changes to cos, so I could write this as cos of x, right? Now let's look into the next one, which is pi minus x. So if you take away from pi x, then you are right there. Now sine is positive in quadrant 2, correct? You know your rule. All are positive here. Sine is positive. Tan is positive in quadrant 3. Cosine in 3. Since sine is positive again, and this is pi minus x, so it remains sine and it becomes sine x. The third one is 3 pi by 2 minus x. So if you do 3 pi by 2 minus x, you are in which quadrant? You are in quadrant 3. Now in quadrant 3, sine is going to be negative, right? So that is one thing. Second is that sine changes to cosine since it is 3 pi by 2. So it becomes negative cos of x. Well, when we say x, cos x, you are in quadrant 1, everything is positive, but we are looking for a negative value, right? The last one here is sine 2 pi minus x. 2 pi minus x means you are in this quadrant, correct? So that becomes 2 pi minus x. Here again sine is negative, so we can write this as minus sine x. It is important to remember that whenever you have something like this, pi by 2 minus x or 3 pi by 2 minus x, in that case we are looking into co-function. Sine becomes cos, cos becomes sine, right? Now if you look into this, what do we have? We have cos x minus cos x plus sine x minus sine x, which is indeed 0. So that is what it simplifies to, right? So I hope the concept is clear. I took my time to explain you how to work with these angles and how to do this question without using compound angle formula. Question number 2. Show that cos A minus B equals to cos A cos B plus sin A sin B for A equals to 5 pi by 2 and B equals to 2 pi by 3. Now if A is 5 pi by 2, then what is the location? Let's try to locate it. So for A, we have 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2. We're right there. Now in this particular case, if you are at that point, then what is sine A equals to? Sine 5 pi by 2 is going to be 1 and cos 5 pi by 2 is going to be 0. Right? Now let's look into the second part, which is B is 2 pi by 3. So let me again sketch this. When I say B is 2 pi by 3, that means we are in this particular quadrant, so that is B. Now in quadrant 2, we know only sine is positive, right? Acute angle is pi by 3. Since that is the case, we can write sine 2 pi by 3 as what? Let me draw this special triangle also, so that's very clear to you what we're trying to do. The whole idea is to understand the concepts. So here is the pi by 3 angle, which gives you 1, 2 square root 3. So sine 2 pi by 3, and sine is positive here, will be positive square root 3 over 2. And cos 2 pi by 3, since you are in quadrant 2, is going to be negative, and the value is half. Right? So these are the values which you have to substitute in the given expression. Now one more thing which you have to calculate is A minus B. So what is A minus B? A is 5 pi by 2, right? And you have to take away 2 pi by 3. So you have to calculate this also. Common denominator is 6, so you get 15 pi minus 4 pi. Which gives you 11 pi by 6. Now what is 11 pi by 6? 11 pi by 6 means that, if you divide the whole thing in circle, you get 12 pi by 6. 11 pi by 6 is kind of here, right? So that is 11 pi by 6. So you are in quadrant 4 where cos is positive, right? You are in quadrant 4 where the cos is positive. Okay, now let's begin to solve the question. So on the left side, we have cos of A minus B. A is 5 pi by 2. So we'll write 5 pi by 2 minus B, which is 2 pi by 3. Correct? On the right side, cos A cos B, that means cos of 5 pi by 2 times cos of 2 pi by 3. Plus sine A sine B. Sine A means sine of 5 pi by 2 times sine 2 pi by 3, correct? So as we just worked out, we could write this as cos of let's do all the steps. 6, and we have 15 pi minus 4 pi on the right side equals 2. Okay. Okay, so I'll further go here on the left side. Cos of 15 minus this is 11 pi by 6 equals 2. Now cos 5 pi by 2 is 0. So we get 0 times anything which was minus half, plus sine 5 pi by 2 is 1 times 2 pi by 3 is square root 3 over 2. Right, that's what we get. On the left side, cos 11 pi by 6, you're in quadrant 4, could be written as cos pi by 6, right? And here we get 0 plus square root 3 over 2. And cos pi by 6, that is the triangle, is indeed equals to square root 3 over 2. And on the right side also, we get square root 3 over 2, right? So we see that left side equals to right side. And that is how we can show that the formula really works for all the values, including the values given here. Clear? Question number 3. We need to show that tan 2 pi minus x is minus tan x. Let's apply the formula here, which is tan a minus b, right? So we could write tan 2 pi minus x as tan of 2 pi minus tan x over 1 plus product of these two, right? Tan x. Now cos of 2 pi is 0, so we get 0 minus tan x over 1 plus 0, and that is indeed minus tan x, which is the right side. Okay. Question number 4, we need to solve this equation. Equation is square root 2 sine 5x plus 1 equals to 0. We can write this as square root 2 sine 5x equals to minus 1. So sine 5x is equals to minus 1 over square root 2. Now there are a couple of things which we have to look into. We are given that x is between minus pi and pi. So that means that 5x will be between what? Minus 5 pi, correct? And 5 pi. And this is important to understand. Okay. Now we are looking for solution that sine 5x is negative. That means that the solution could be in quadrant 3 or in quadrant 4. And 1 over square root 2 means the acute angle here is pi by 4, right? That's what it means. So if we are looking at the values which are let's say in the let's go to the right side. Okay, so what we're looking for values is that 5x is equal to, because this is like one value could be that much, which is how many pi by 4s? 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, right? So we'll go from 0 to positive this, and then we'll go negative side also. Okay. The other one is, now this is 5, this is 6, this is 7. So we get 7 pi by 4. Correct. Now we have to add to this another circle. We are going to 2 pi, right? So we've done 2 pi. Now we'll add, we keep on adding. So 2 pi, when you add 2 pi in terms of pi by 4s, could be written as 8 pi by 4. Is it okay? 8 pi by 4. So basically we'll add 8 to these. So if I add 8 plus 5 is 13. So we get 13 pi by 4. 8 plus 7 is 15. So we get 15 pi by 4. When it is 5 pi means we cannot go above 20, right? So again, let's add 8 to this. So when you add 8 to this, it becomes how much? 21. So you cannot go, because 5 pi is basically equals to 20 pi by 4. Is it okay? So that becomes the limit. Right? On the other hand, you could go negative also. So you could go negative like this. So you get negative pi by 4 as your first position, right? Negative pi by 4. So we go negative pi by 4. And then if you go like this, what is the angle? Negative 2, 3. So negative 3 pi by 4. Correct? Now again, we do negative, we add 8 to this, so minus 9 pi by 4. And 8 and 3 is 11, so it becomes minus 11 pi by 4. Right? Now if you do 8 here, you get 19, so that could be one answer. So let me add 8 again here. So 1, 2, 3, 4, 5, 6, 7, 8. And if I go 8 on this side, so minus 8 will be minus 17. Let me write here only. Minus 17 pi by 4. And minus 8 gives me minus 19 pi by 4. Correct? So these are all the solutions which we are going to get. So we get how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, one period is basically 2 pi for the normal cycle. Here we have 5 of these, right? So we are getting, instead of 2 solutions, we are getting 5 times 2, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does it make sense to you, right? So that is very important to understand. So that is all the solutions. Now we have to divide them all by 5 to get the x value. So x is equals to, dividing by 5, the first one will give us, okay, so here 5 cancels, so we get pi by 4. In the second one, it is 7 pi by 20. And then we have 13 pi by 20. 3, right? So if you do 5 division, 3 pi by 4. So I'm doing 2 steps at one time. So minus pi by 20. Here we get minus 3 pi by 20. And then here you get minus 9 pi by 20. And then here minus 11 pi by 20. Then minus 17 pi by 20. And minus 19 pi by 20. Do you see that? So that becomes your solution set for the given question. So I hope it is absolutely clear. Question number 5. Solve 2 sin x equals to 3 cot x, where x is between 0 to 2 pi. So let's rewrite the question. It is 2 sin x equals to 3 cotangent x. So let's bring them together. 2 sin x minus 3 cot x equals to 0. Now we'll write cot x as ratio of cos and sine. So we get 3 cos x over sin x equals to 0. Common denominator could be taken as sin x. So we get 2 sin square x minus 3 cos x equals to 0. Let's write sin square x in cos square x so that we get a quadratic equation in cos. So it is 1 minus cos square x minus 3 cos x over sin x equals to 0. So if you open it, you get 2 minus 2 cos square x minus 3 cos x over sin x equals to 0. Now, for this equation to be true, numerator should be 0. Is that okay? So we'll equate the numerator as 0. So let me rearrange and write this as minus 2 cos square x minus 3 cos x plus 2 equals to 0. So we could actually multiply by minus just to get rid of these numbers. We get 2 cos square x plus 3 cos x minus 2. The idea is to work with positive leading coefficient, right? Now we can factor 2 times 2 is 4 minus 4. we need plus 3. So we could factor this as 2 cos square x plus 4 cos x minus cos x minus 2 equals to 0. Taking 2 cos x common in the first two, we get cos x plus 2 minus cos x plus 2 equals to 0. So we have cos x plus 2 as common factor and 2 cos x minus 1 as the other factor. So what solutions can we get? We can get solutions as cos x equals to minus 2. That is no solution, right? This is no solution. The other one we could get as cos x equals to half, right? Now from here we get no solution. Since cos value is less than or equal to, absolute cos value is less than or equal to 1. Now cos x equals to half, we do have a solution here. So we know our special triangle, 1 square root 2, and that angle is pi by 3, right? So we have two solutions for this. One is x equals to pi by 3. The other one is that it could be in quadrant 4, right? So cos is positive in quadrant 1 and 4. So it is 5 pi by 3, right? So second answer will be 5 pi by 3. So these are the two solutions for the given equation in the given domain of 0 to 2 pi. Correct? So we can write down our answer as x equals to pi by 3 and 5 pi by 3. Let's move on to question number 6. Provide counter example to show that cos x plus cos 2x plus cos 3x is not an identity. So for that, you can take any value of cos x, right? Sometimes you may get that they are same. For example, if you take pi by 2, you may or may not. Okay, so let's take a cos value as, for example, let's try cos x equals to 0. Okay, now we know if I write 0 here, okay, then what do I get? So we get cos 0 degrees plus cos again 0 degrees is equals to, let's check, is it equals to cos 3 times 0 degrees? Well, cos 0 is 1, we get 1 plus 1, and this is also 1, so that is not true. Is it okay? So straight away, taking examples can show you that's not an identity. Does make sense to you, right? So that is how you could actually easily do it. So that shows, since left side is not equal to right side for x equals to 0 degrees, it is not an identity. For identity, it should be valid for all values of x in its domain, right? So even if you provide one example, it is enough to show that's not an identity. Question number 7. We need to prove that sine minus x over sine pi plus x minus tan pi by 2 plus x over cot x plus sine pi by 2 plus x over cos x is 3. So let's rewrite the values. So when you say sine minus x, what is sine minus x is equal to? Well, sine minus x is minus of sine x, right? So we can say that the left side is equals to, let's rewrite, sine of minus x over sine of pi plus x. Then we have minus tan pi by 2 plus x. That becomes cofunction. It gets converted to cotangent, right? Plus sine of pi by 2. That's again cofunction. It gets converted to cosine. So sine minus x is actually minus of sine x. And sine pi plus x is also minus sine x. And here we have cotangent. So tan becomes cotangent. So numerator becomes cot x. We already have cot x in the denominator. Since it is pi by 2 plus x, it is minus cot x. Do you see that? Now the third one, pi by 2, sign is positive in quadrant 2, so that remains positive. So we get this as cos of x, and we have cos x. So what we get here is 1 minus minus 1 plus 1, and that is indeed 3, which is the right side. Okay, so that is how we can do it using cofunction identity. Question number 8. You need to show that product of tan x plus y times tan x minus y is equals to sine squared x minus sine squared y divided by cos squared x minus sine squared y. So we can start from the left side. Tan x plus y is what? Tan x plus y is tan x plus tan y over 1 minus tan x tan y. And tan x minus y is tan x minus tan y over 1 plus tan x tan y. So when you multiply, a plus b times a minus b is equals to a square minus b square. So difference of square. So we get tan square x minus tan square y divided by 1 minus tan square x tan square y, right? Now tan could be written as sine over cos. Okay, so what we can do here is we'll just write tan as sine over cos. So we get sine square x over cos square x minus sine square y over cos square y over 1 minus sine square x over cos square x times sine square y over cos square y. Correct? Now if I multiply by cos square x cos square y, then we get sine square x minus sine square y in the numerator, and this becomes cos square x cos square y minus sine square x sine square y. Now what we can do here is that we can write cos square y as 1 minus sine square y, right? Since we want only cos square x here. So we get numerator as sine square x minus sine square y. In the denominator, we have cos square x times 1 minus sine square y minus sine square x, or sine square y we need. So we'll keep sine square y. Write sine square x as 1 minus cos square x. Okay? So that gives you, in the numerator we have sine square x minus sine square y, the required result. Let's expand this. So we get cos square x minus cos square x sine square y. Expand this, minus sine square y, and then minus minus becomes positive, sine square y cos square x. Correct? So as you can see from here, these two terms cancel out, and you are left with what is required, which is sine square x minus sine square y divided by cos square x minus sine square y. Correct? So that is how you are going to prove this particular identity. Now let's move on to question number 9. We are almost at the end. Question number 9. Prove tan x equals to 1 minus cos 2x plus sine 2x divided by 1 plus cos 2x plus sine 2x. Now we'll apply the compound angle formulas, double angle formula. We know what sine 2x is. Sine 2x is 2 sine x cos x. And cos 2x is you could write different formulas for it. We could write cos square x minus sine square x. Correct? So these are the two formulas which we are going to use now. So we'll begin with the right side, which is given to us as 1 minus cos 2x plus sine 2x divided by 1 plus cos 2x plus sine 2x. Now we'll write as discussed here. Left side could be equals to 1 minus cos 2x. I'm writing as cos square x minus sine square x, and sine 2x as 2 sine x cos x divided by 1 plus cos square x plus sine, minus sine square x, and then plus 2 sine x cos x. Now in the numerator, you can see 1 minus cos square x, and then we have minus sine square x. So 1 minus cos square x could be written in terms of sine, correct? So in the numerator, we can combine these two terms, 1 minus cos square x, writing that as sine square x. So we have sine square x, and we have this minus and that minus becomes positive sine square x, and here we have plus 2 sine x cos x. Right? So let me expand and add that step. So we'll write 1 minus cos square x plus sine square x plus 2 sine x cos x, correct? Divided by, now we'll rearrange, we'll write this as 1 minus sine square x. Then we have plus cos square x plus 2 sine x cos. I hope that is better. Now let's get back to this. So 1 minus cos square x is sine square x, and rest I've copied. 1 minus sine square x is cos square x. So in the denominator we get cos square x, correct? Plus cos square x plus 2 sine x cos x. Now here we get this term as 2 sine square x, and we have plus 2 sine x cos x divided by 2 cos square x plus 2 sine x cos x. We can take 2 sine x common in the numerator. We are left with sine x plus cos x. In the denominator, we can take 2 cos x common. So we are left with cos x plus sine x. Now these terms cancel. 2 and 2 cancel. So what we get here is sine x over cos x, which is indeed tan x. So which is the left side. So we have shown that right side is equals to left side. So that is how you could prove this identity. Okay, let's move on to the last question. I hope you are learning as we solve these questions. Question 10. How many solutions do you expect to have for the equation? We are given the equation as cos x minus 2 times 2 sine x minus 1 equals to 0, and the domain is that x belongs to from minus pi to 3 pi. How many solutions do you expect? Well, we don't have to really solve, but here there are no solutions, since cos x can never be equal to 2, right? And in this case, we have basically sin x equals to half, correct? So in one cycle, there are 2 solutions. Right? So we have 2 solutions in one cycle. In one cycle, correct? So what I'm trying to say here is We are given a domain minus pi by, let's sketch this, it will be easier. So let me sketch a sine wave. Okay. And let's say kind of like this. Right. So we are going from minus pi to, so let's say we have it here. So when I say minus pi, that means we are here. This is minus pi. And when we are saying that we have to go half means this line. Okay. Now one side, on the negative side, we do not have any solution. So when we are going to 3 pi, so this is like 1 pi, 2 pi, this is 3 pi, right? So that is 3 pi for you. So we have 1 solution, 2 solution, 3 solution, 4 solutions. You see there are 4 solutions. So we have 4 solutions for this equation. Correct? So that is how we can actually communicate how many solutions we have for the given equation. I hope that helps. So in this particular test paper, you saw how we can use the co-function identities, correlated angles, and compound angle formulas to solve these given questions. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe my video, that'd be great. Thank you and all the best.